All right, welcome back. In a recent video, we showed how to use Ollama and Open Web UI to host your own large language models at home and have a ChatGPT-like web UI in front of them. Today, we're going to show you how to use the same toolset to integrate with your own data, enabling you to use large language models to ask questions about your own data set, completely private, just as we showed before. And if you're new here, hi, this is Sonoran Tech, where we cover a wide range of tech topics from hardware to home labs to coding and current events. If you like the content, hit the sub button and leave a comment to let me know what topics you're interested in seeing. So I'm going to arrange this video in two parts. First, we'll jump right into the tools and show you how to set up this capability so you can get up and running quickly. And then next, we'll dive just a little bit deeper and explain what is happening behind the scenes when you essentially bring your own data to large language models. But before we do that, why would you even want to do this? Well, privacy is probably the number one answer. You can upload documents and data sets to tools like ChatGPT or Anthropic, I think you can also do that with, but you're basically giving your information to another service provider and potentially very sensitive or large amounts of information. And many people don't want to do that. And so running your own models at home and creating your own knowledge bases, or I think the formal term would be a RAG database, is very appealing from a privacy perspective. And the second reason is cost. Using the tools we're going to look at, you can create your own knowledge repositories that can be used across different models and interaction sessions. These features are often only available through paid subscriptions to services like ChatGPT, well, OpenAI services. So, you can run it at home, it's affordable and private. So a pretty interesting space to explore. So with that, why don't we get started and get this set up? So in front of us, we have the Open Web UI, which we set up in a previous video. And what you're going to do is you're going to select Workspace right here. You're going to select the Knowledge tab. And what you're going to do is you're going to come over here and select Plus, and we're going to create a new knowledge base. And I would just call this like Test Knowledge Base. I'll put test in here. You have to fill out both of these, and we'll just do create knowledge. And it's that simple. And so what we need to do now is add documents to the knowledge base. Now this supports many common file formats, and I actually went through the source code to try to find it. And you can do that if you go to the Open Web UI GitHub. You can actually find all the file extensions it supports. But I think your common files like text, CSV, it might even support Word documents, etc. It's not perfect, but what I'm going to do is just to build out our sample knowledge base for this test, I keep a bunch of my content and scripts for the YouTube videos I create in, I create them using Obsidian, and all that is stored in Markdown files. So they're basically text files. They're super simple. And here's an example of one of those text files. Right, simple Markdown, and Obsidian is just a layer over that. So what I'm doing is I have a directory full of all of these files, which I've used. There's a total of 25 of them. So I'm just going to drag those right into here, and they will get uploaded to this knowledge base we created in Open Web UI. All right, that is it. So we click back to the knowledge tab, you can see we have our test knowledge base. And so this has been imported into Open Web UI. These files have been converted into an embedding format, and we'll get to that later, and they're effectively stored in something like a database. But now we can use this knowledge base in a chat. So I'll show you. We'll just come over to a new chat. I'm going to select, we'll use the Gemma model since it has 27 billion parameters. Now to use the knowledge base in a chat, all you do is hit the pound sign, and you can see here it is right here. And so that just adds it as context for the chat you're about to have. So now we can ask it a question. And so I know I did a script in a video on CUDA programming, so I can say, summarize the script on CUDA, and we'll see what it does. And here you go. It says the CUDA script starts with the basic hello world example, talks about driver and toolkit compatibility, and then it implements vector addition in C. So yeah, this is reasonably correct. And you can see right here the sources it used, and these were the files I uploaded into the knowledge base. So not bad. And so you can continue to have a conversation around that, and you can say, well, does it talk about what CUDA is? Meaning, like, do I even explain what CUDA is in the video? And here you go. The answer is yes. I did explain what CUDA is, and it summarizes it here, again, citing the documents it used for that. Now, let's kind of ask a more broad question. And so I've done some videos on home lab projects, and I actually think you'll see this is not a perfect solution. And I think this example will demonstrate this well. So tell me about all of the home lab projects I have written about. Now I did 2 videos with 5 projects each, so that's a total of 10. What I'm hoping is it tells me about all 10 projects. So let's see what it does. And it says I wrote about 5 projects. That is not correct. And the projects look right, but this is not all I've written about. And you can see the source of this is 5 more home lab projects. And then the script for a short I did around that, but that is not the whole answer. So I'm going to try this. Tell me, I'm going to say to it, I thought there were 10. So it says I can only find information about 5. I'm going to tell me, no, there were 10. Tell me about all of them. It says you were right. I missed some projects. So let's see. It's interesting. So it continues the list we had before. Home network, PSNs, Nextcloud, automating tasks with Ansible. You know what's interesting? This is not right. So you can see these were actually 5 projects I wrote about. And I think these additional ones, I think I talked about in a script, or it was like secondary content. It wasn't like the top 5. So you can see I actually forced it into making a mistake, but it did do it based on the context I provided. So, you know, it is what it is there. And then I'm just going to say, okay, well, forget that. Never mind. Forget all of that and summarize all of the scripts on VLANs. Now, I think I had 3 scripts on VLANs. So here it's a moderate summary at best of the different scripts on VLANs. Can you expand? See, it's interesting because it says the script as if there's one script, but there's actually many, and you can see them referenced down here at the bottom, but it's fine. For, you know what, for setting something up in all of a few minutes, I'm going to give it credit as being pretty darn good. That's it. Like, that is the real quick how you set up a knowledge base and bring your own data into Ollama and Open Web UI. And as you can see, is it perfect? No. But did it work out of the box in a few minutes? Yep, it was pretty good. And I'll let you go play with it a little more from here. So what we're going to do now is let's shift gears a little bit and talk a little bit about how this works under the hood, just a little. And what we're going to do is we're actually going to use our Ollama and Open Web UI to guide us through this learning process of what's going on. And so we're going to start to ask this a question, and we're going to ask it, how are questions passed to a large language model? Because the first thing, like before you understand like how you pass in this database or how the database gets used, you need to understand when you write a question like the one in front of us, how does that actually get passed into the model? So obviously it takes the input and it tokenizes the text into individual units called tokens, which can be words, parts of words, or punctuation marks. And this is the important part, embedding. Each token is converted into a numerical representation, a vector, that captures its meaning and relationship to other words. This is a process called embedding, and the embedded tokens are fed into the LLM neural network. And so basically, you can think of the inputs to the LLM as these vectors. And then the output generates a sequence of vectors, and they get converted back to text. The tokenization and embedding parts are the key thing to understand. But let's see if we can get a little more information out of this model. So show me an example of an input sentence and what an embedding looks like. It's very enthusiastic. You're right to ask. So it's hard to show a precise embedding. I'll wait a second. Right, so it's hard to show a precise embedding because they are typically high dimensional vectors, hundreds or thousands of numbers. Imagine trying to visualize a point in a 500-dimensional space, but a simplified example. And this is really interesting to look at. So imagine you have a sentence, the quick brown fox jumps over the lazy dog. The hypothetical example would be this vector of numbers, right? And that's roughly what it's going to convert your input sentence into. And each number in the vector represents a feature or aspect of the sentence's meaning, and right, the specific values don't have direct interpretation. The pattern across all the numbers captures the semantic relationships. Great. So this gives you a rough idea of what's happening behind the scenes. You type in a sentence, it gets converted to a numeric vector based on an embedding algorithm, and that gets fed into the model. Now, if you want to learn a little bit more about how large language models work, I will put a link to an awesome introductory video up here. So now we understand a little bit about how text is converted to inputs to a model. Now, imagine you're thinking about the problem we just demonstrated. You want to pass in a whole bunch of documents to a query. And so you're essentially, what you're doing when you build these knowledge bases is performing this embedding process ahead of time. When the documents are uploaded, and we'll just go back to workspace and knowledge. When we created this knowledge base and uploaded the documents, they are converted to an embedding format, that kind of numeric vector we saw, and they're stored locally. And then when you go and run a search, when you run a query, and you tell it to include the knowledge base, it's basically pulling that vector data out of the knowledge base and including it in the query which is sent to the model. And you can get a little sense of how that is working is by going into settings, going into admin settings, and selecting documents. And here you go. You can see this is where it kind of sets up the embedding engine it uses. You can change the embedding model, the algorithm it's using to produce those numeric vectors. And then here's the template, which is used behind the scenes to pass in your knowledge bases to the model, right? And it even gives like the rules. It gives some rules to the underlying model of how to interpret everything. And you could go change this if you want to kind of tweak the model to get different results based on your data. So this is a good thing to play around with. The other thing you can do is, if you want, you could actually change to a different embedding engine. You could use Ollama or OpenAI. And I'll leave this as an exercise to the reader to play around and see if it kind of changes your results or makes them better for you. But I'm going to go back here, and what we just showed and touched on super briefly was something called RAG. And so we'll ask it, what is RAG? So what is RAG? RAG stands for Retrieval Augmented Generation. It's a powerful technique that combines the strengths of traditional information retrieval engines with generative capabilities of large language models. So kind of what you just saw was a very simplified RAG system. So typically what will happen is you'll take a bunch of information. Like imagine you have a large document repository. You will build it's called a vector database, which is a database of those numeric vectors we showed. And then what happens is when you go to run a query against a large language model, you will actually first query the vector database. So there's a whole separate query process that happens to get matching information out, and then that gets passed in as context to the large language query. Similar to what we saw in this example here. You can actually build much more robust RAG applications and optimize that database, etc. Here we really just scratched the surface of a RAG system, but we showed how to bring your own document repository in and get it up and running. So we're going to leave it there today. If you have any comments or questions, leave them down below, and we will see you next time.